Imagine a construction site. You know, the rumble of machinery, that smell of fresh concrete, just the sheer scale of it all.
Yeah, it's an industry built on really tangible things,
Yeah.
right? Steel, wood, pure grit.
Exactly. And for, well, millennia, it was totally analog, physical blueprints, hands-on craftsmanship.
A world away from where we are now, in many ways.
But what if we told you there's this invisible force now, a new kind of expert who's fundamentally reshaping how these huge projects come to life?
Mm-hmm.
We're talking about a role that's, well, it's as critical to a building's success today as the foundations it sits on.
That's a great way to put it. It really is foundational now.
Welcome to the Deep Dive. This is where we take a stack of your sources, could be articles, research, our own notes, and we really pull out those crucial nuggets of knowledge for you.
Get right to the core of it.
Today, we're plunging into the, I think, fascinating world of the construction technologist. You might hear them called a context specialist.
Contech, that's the term cropping up everywhere.
So this deep dive, it's all about understanding this pivotal role. It's emerging right at that intersection, you know, the traditional job site and the modern IT department.
It's a fascinating crossroads.
You'll learn what they do, the incredible tech they have to wrangle, and why they're not just becoming indispensable, but really, truly driving the future of how we build.
Indeed. What's so interesting here is seeing how an industry that was, let's face it, pretty analog for so long is just rapidly digitalizing.
Right.
And that's creating entirely new demands, new opportunities. Our sources today, they lay out a really compelling case for why this role isn't just like a passing trend.
No, it feels much bigger than that.
It's a strategic imperative. So we'll be looking at everything from, the big foundational shifts driven by data all the way down to the specific tools and skill sets that define this new breed of builder.
Basically giving you that shortcut, helping you get well-informed on this critical shift, maybe even a career-defining one in the construction world.
Exactly. Helping you understand what's happening under the hood.
Okay, let's unpack this.
The digital groundswell. Why the construction technologist is essential.
So for millennia, construction was, hands-on, completely analog. Think about the precision of Roman builders or those incredible details in 16th century texts like De Re Metallica.
Right, that's that amazing book on mining and metallurgy.
Exactly. It describes everything, sieving ore by hand, building these complex furnaces with exact dimensions, all done with physical tools, paper plans, just immense human effort.
No CAD, no BIM back then.
Not a chance. Even Vitruvius, his architectural designs were all about physical materials, proportions, how to build walls, place columns, manage water with lead or clay pipes.
Every single process, design to execution, it was purely manual input, keen observation, centuries of know-how passed down.
Knowledge held in the minds of master craftsmen, etched onto blueprints. That was the world.
And then you connect that to today, it's just a different planet. As one of our sources, the City of Tomorrow highlights, almost every contemporary action and interaction create data.
Data everywhere.
This massive profusion of urban big data fundamentally changes how we interact with our physical environment and, crucially, how we build it.
So construction couldn't stay immune.
No way.
Yeah.
Despite those deep roots in the physical, it just couldn't remain untouched by this third industrial revolution, a concept also mentioned in Designing Reality regarding digital fabrication.
Third industrial revolution. Digital.
Exactly. Digital data, connectivity, automation. And this isn't just about adding a few computers to the site trailer. It's a wholesale reorientation of knowledge, of power.
A shift from paper plans and gut feelings to what? Digital streams and data-driven insights?
Precisely. And the really profound insight here isn't just that data helps you build better, although it does. It's that the value of the physical building itself is increasingly tied to its digital counterpart, its digital twin.
How so?
Well, think about it. That digital information influences everything from resale value to maintenance costs over maybe 50 years. It means moving from designs based primarily on intuition and experience.
Which are still valuable, of course.
Absolutely. But augmenting that intuition with precise, real-time data. And that creates a need for a new kind of expertise. Someone who can bridge those two worlds, the physical grit and the digital code.
It's more than just a transformation then. It's, like you said, a redefinition of the whole building process, driven by this almost overwhelming flood of information.
It is overwhelming, potentially.
And it's not just about speed, is it? It's this reorientation of knowledge, of power you mentioned, Traditionally, maybe the seasoned superintendent, their wisdom won over decades, they made the call.
Right, based on experience.
But now, with a construction technologist involved, that same decision might be informed by predictive analytics from BIM, maybe real-time drone data from the site.
Historical performance data from similar jobs.
Exactly. So intuition gets augmented, maybe sometimes even challenged by hard, verifiable data.
Which doesn't just make projects more efficient, although that's a big part of it. It fundamentally changes the knowledge hierarchy on a job site.
How does that play out?
Well, it empowers new roles, like the contech. And it raises some pretty crucial questions about accountability in this new digital landscape. Who owns the data? Who's responsible if the model is wrong?
Interesting point. So this deep dive, it's going to help you, the listener, navigate how construction is adapting to this huge change and what it means for how you understand the industry.
Yeah, what it means on the ground.
Because our sources, they make it really clear. The modern job site is just awash in new software, hardware, and data.
Absolutely swimming in it.
We're talking about a genuine technology stack, like in software development, but for construction. And without careful management, that stack can cause chaos, not efficiency.
That's the risk.
Yeah.
Imagine a project you've got advanced 3D modeling, drones flying, daily capturing reality, complex scheduling platforms, cloud docs, maybe IoT sensors on equipment, communication tools.
A lot of moving parts.
A ton. And if they're all operating in isolation, that mishmash of open source and proprietary CAD and CAM software, as one source puts it, it creates friction, fragmentation.
So instead of synergy, you get data stuck in silos, missed updates, critical info lost.
Precisely. Undermining any potential benefits.
Yeah.
It's like having this amazing orchestra, all brilliant musicians, but no conductor.
All the talent, but no harmony. The performance suffers.
Exactly. And that raises the big question. How do you manage this explosion of information without it just becoming overwhelming noise?
Yeah, how do you get control?
Well, as the goal reminds us, a great book on constraints. By the way, data management alone isn't going to give us more control. Just having data isn't enough.
You need more.
You need structure. You need strategy. And crucially, you need a specialist, someone who gets both the technology and the unique pressures of a construction site.
That blend together.
That blend is key. So the need for a dedicated expert to actually manage a company's technology stack becomes crystal clear.
It's not just knowing the tools individually.
No, it's understanding how they interact,
Well,
how data flows or should flow between them, how to optimize that flow for project success.
making the tech serve the project, not the other way around.
You got it. It's about creating a coherent digital ecosystem where every piece of tech adds value to a unified, efficient workflow rather than just adding more complexity.
And without that central figure, that contech.
Firms risk real economic pain from that fragmentation. Missed deadlines, costly rework, disputes over who has the right version of the plan, even safety hazards from miscommunication.
So the context steps in to prevent all that.
They're the ones who mitigate those risks. They conduct the orchestra.
Okay, making the tech serve the project. But things change so fast in tech. How does a contact make sure they're picking tools that genuinely help, not just chasing the next shiny thing?
That's a huge part of their strategic value. It's not just about having the tools, it's making them work together, making them meaningful, integrating them properly.
So how does that translate into value, especially for the people paying the bills?
Well, look at it from the owner's perspective. One source, the BIM handbook, flat out states the owner is in the position to benefit most from using BIM, building information modeling,
Why the owner specifically?
because it enables competitive advantages and a better return on their capital investments. BIM lets owners visualize the whole project lifecycle, make informed decisions early on, materials, maintenance plans, you name it,
Proactive risk mitigation too, I imagine.
big time, leading to significant cost savings and better quality over the long haul. And service providers, contractors, designers, they're also leveraging tech for their own competitive advantage.
How are they using it?
Streamlining processes, improving collaboration, boosting safety, delivering projects faster, more efficiently. That helps them win more work, secure better contracts.
So this whole digitalization thing, it's not just keeping up, it's about getting ahead, leading the pack.
Absolutely. It's about carving out a stronger market position, even changing the risk profile of projects, and having a context to strategically implement and manage these tools. That's not just spending money.
It's an investment.
It's a calculated investment,
Yeah.
one that yields substantial returns across the entire project lifecycle, from design right through to operations.
So, what does this all mean for you, the listener? It means understanding this role isn't just, learning another job title. It's about understanding the future of the entire built environment.
It really is.
This deep dive, it's your shortcut to getting informed on this critical shift. The construction technologist is becoming a strategic asset, a key player.
Ensuring firms can innovate, operate efficiently, manage risks, stay competitive in this increasingly digital world.
And the big insight here, maybe the catchphrase for the whole thing, data is truly becoming as important as concrete and steel.
It's the invisible scaffolding, like you said. Essential.
Here's where it gets really interesting. Let's dive into the actual tools. The Context Digital Arsenal.
The Context Digital Arsenal exploring the technology stack.
Okay, the arsenal. First up, the big one. Building Information Modeling, BIM.
Right. If you're building today, BIM is it's your blueprint, your spreadsheet, your crystal ball, kind of all rolled into one.
That's a good summary. It's definitely seen as a superior design environment compared to old school 2D CAD.
Why superior?
Because it's capable of 3D parametric modeling. That captures design intent. Think intelligent, information-rich 3D objects, not just flat lines.
Objects that know what they are. A wall knows it's a wall.
Exactly. And it knows its relationship to other objects, the floor, the roof, the window inside it. It's not just visualizing in 3D, it's creating a digital prototype packed with data.
Dimensions, materials, costs.
Scheduling info, energy performance, you name it. It makes it so much more intuitive and powerful for visualizing, conceptualizing, truly understanding a project from day one. Way beyond static drawings.
But it's not just about pretty pictures, right? That seems to be a common misconception.
Not at all. That's a key point. As the BIM handbook explains, it's a comprehensive tool. It supports coordination, estimating, scheduling, project management, the whole life cycle.
And you mentioned analysis earlier.
Yeah, another source, the CMAA standards, talks about specific benefits like engineering analysis, using that digital database of the building's characteristics for simulations.
Like what kind of simulation?
Structural integrity checks, predicting energy consumption, analyzing daylight penetration, simulating how the building will perform before you build it.
So you could optimize the design for energy efficiency using BIM.
Absolutely. Optimize building orientation, window sizes, insulation levels, maybe even aim for net zero energy. We see examples of that happening. It leads to better, more sustainable, more resilient buildings. Optimize for the long-term, lower operating costs. That's a huge win for owners.
Okay, so BIM is powerful. But getting all the different design disciplines, architects, engineers, MEP folks, to work together smoothly within it, that sounds like a challenge.
It is, and that brings us to a specific role our sources mention. The BIM integrator.
A BIM integrator, what do they do?
They're the facilitator. They run those crucial design review meetings, ensure better coordination among various disciplines, often using things like virtual hard-at reviews.
Virtual hard-at reviews, like walking through the building digitally.
Exactly. Literally walking through the 3D model together, maybe in VR, before it's built. Imagine spotting a pipe hitting a beam in that virtual space.
Instead of finding it out on site.
Right. Where fixing it is vastly more expensive and time-consuming. This proactive clash detection, it's a total game changer. Fosters collaboration, prevents costly mistakes, saves millions, keeps projects on track.
So the Contech often plays this BIM integrator role.
Very often, yes. Or they manage the person who does. And that brings up another critical question. How do you get all these different software systems from different companies, different disciplines, to actually talk to each other? Interoperability.
Yeah, that sounds like a nightmare.
It can be. The BIM handbook points out the challenge of time-consuming manual data input just to get data from one system into another for analysis.
How do you solve that?
The key is standards. Specifically, the IFC Standard Industry Foundation classes. IFC creates new possibilities to achieve interoperability for design software.
IFC is like a common language for BIM data.
Pretty much. An open data format. A universal translator allowing different software from different vendors to exchange BIM data intelligently.
Are there examples of this working?
Yep. The source mentions a collaboration, Olaf, Granlund Oy, Lawrence Berkeley Labs, MIT, Halton Group jointly developing something called BS Pro ComServer to achieve IFC compatibility between specific tools like MagicCAD, BSLCA, and Ryuska.
So this interoperability, it's crucial for the Contech.
Absolutely critical. They have to ensure that seamless flow of information across the whole tech stack, turning isolated islands of data into a cohesive, intelligent network. Without that, the full potential of BIM just isn't realized. You're back to fragmentation.
Okay, so BIM and IFC help get the digital house in order. But how do you make sure that digital model accurately reflects the messy reality of the physical job site?
Ah, the bridge between physical and digital. That's where reality capture comes in.
Laser scanning, drones.
Exactly. Laser scanning is a cornerstone. One source gives a great example from Skanska, the contractor. They used a surveyor with a Trimble VX spatial station.
What did that do?
It's a two-in-one solution, tachymeter and camera. It could capture coordinates, take images, and combine them. Made the surveyor's job much easier. A two-person job became a one-person job.
More efficient. And you mentioned drones.
Drones are huge now, too, for drone surveying.
Yeah.
Capturing vast amounts of site data incredibly quickly, feeding it back into the BIM model.
Like mapping the site progress.
Yep. Comparing the as-built reality against the as-designed model. The City of Tomorrow talks about this more broadly, the physical world being sensed on a tremendous scale and turned into actionable digital data.
So you can constantly monitor conditions, track progress, spot deviations.
Precisely. Imagine documenting every pipe, beam, slab with millimeter accuracy, then overlaying that scan onto your BIM model. You see instantly if something's off.
The amount of rework that prevents must be staggering.
It really is. It closes that loop between design and reality continuously.
Okay, the potential for precision there is huge. So you have the model BIM, you have the captured reality. What next? How do you make that info really work for managing the project timeline and budget?
Great question. That's where intelligent project management software steps up, especially when linked to BIM. Think beyond static Gantt charts.
You mean linking the schedule directly to the 3D model?
Exactly. That's what the CMAA standards call 4D BIM scheduling.
4D. Adding time is the fourth dimension.
You got it. It dynamically links the project CPM schedule activities to 3D objects in the BIM model. What you get is a graphically rich and animated representation of the planned construction sequence set against time.
So you can watch the building come together virtually on a timeline.
Yes, it makes complex sequences much clearer, much easier to communicate, great for phasing, coordinating, and communicating planned work to everyone's stakeholders, site crew, whoever.
Because you can play with it. Like what-if scenarios.
Definitely. Supports simulated what-if scenarios, explore different approaches, spot potential bottlenecks, optimize the schedule before you start building. It's proactive planning, not just reacting.
Planning, not reacting. That seems key. And I think I saw something about 5D, adding cost.
You did. 5D cost management. This means every element in the BIM model can be attributed to what it will actually represent in terms of resources and respective costs.
So the model knows how much each piece costs.
Yep. Leading to parametric and dynamic quantity takeoff for bills of materials and just more accurate estimates. Less time spent manually counting things off drawings.
Which is tedious and error-prone.
Exactly. More time spent on analysis, on value engineering. It's a massive leap from traditional estimating. You get a live, interactive cost breakdown built right into your 3D model.
But integrating all that data cost, schedule, field measurements, that sounds incredibly complex again.
It is. And effective integration is paramount. Remember the goal. One example in another source mentioned needing to integrate 5 different software systems that had the data in it for just one project.
5 systems. That really shows the complexity a contact deals with.
It does. The sheer volume and variety of data demands a specialist who can pull it all together, ensure consistency, ensure accuracy. It also ties into having a uniform cost estimating framework, as the CMAA guide mentions, tracking costs transparently from start to finish.
So the contact is the one making sense of it all.
They're the interpreter, taking all this complex data, these intricate models, and making complexity accessible for everyone. As Tough Day might say, visually displaying quantitative information clearly.
Turning raw data into understandable insights. So the client, the site manager, everyone gets the info they need to make good decisions.
Exactly. Walking them through the project's progress, its costs, its risks, all visually and clearly.
The context's daily impact responsibilities and skill sets.
Okay, so they have this amazing digital arsenal. But who actually decides which tools to put in that arsenal, out of that mishmash of open source and proprietary options?
That's a core responsibility of the contact. They're the ones vetting the technology.
Vetting, like testing it out.
Testing, assessing compatibility with existing systems, looking at vendor support, making sure it meets the project's actual needs, not just picking the shiniest new toy.
It's about ensuring a common footprint for digital fabrication hardware and software, as one source puts it, to make collaboration easier.
Precisely. And it's not a one-off decision. It's constant evaluation, building a strategic tech roadmap for the company, not just for one project, aligning tech with the business goals.
So it involves procurement too, buying the tech.
Definitely. It involves that critical decision-making on acquiring goods and services from outside, as the PMBOK guide terms it, basically tech procurement,
Negotiating with vendors, managing licenses.
evaluating capabilities, ensuring compatibility, managing the integration of multiple database structures like in BIM projects, and ensuring robust document control, which the CMA standards stress is vital.
So it's not just a technical job, it's strategic. Needs a forward-thinking mindset.
Absolutely. Foreseeing future needs, avoiding information silos, managing the whole life cycle of the tech.
Which brings us back to that blend. A deep understanding of construction processes combined with advanced IT literacy.
That's the magic combo. You can't just be an IT guru who doesn't understand concrete pours, and you can't be a site super who's afraid of software.
You need to be fluent in both worlds. Speak the language of architects, engineers, trades, and understand networks, databases, software architecture, maybe even cybersecurity now.
All of it. You're bridging that gap, translating between the two, almost like a cultural ambassador for digital transformation within the company.
And this blend, it ties into lean construction too, doesn't it?
It does, significantly. A lean research guide we looked at points out how tech is increasingly used to enable lean processes, especially the sophisticated integration of lean tools with technologies, particularly building information modeling, BIM.
How does the Contech help with that?
They ensure the tools align with lean principles, helping the team adequately identify and remove constraints in advance of scheduled work.
Like using BIM for better coordination or 4D scheduling to smooth out workflows.
Exactly. Clash detection, optimized scheduling, better resource planning. These all reduce waste, improve flow, hit those lean goals like reducing waiting time or minimizing rework, proactively tackling constraints before they hit the site.
Okay, that connection makes sense. But buying the tech and integrating it is one thing. Getting everyone on site to actually use it effectively, that sounds like a whole other challenge.
It's huge. The Contech is the crucial link here, turning potential information overload into practical, usable knowledge for the team.
Demystifying the complexity, making it relevant.
Yes, making it accessible to everyone, from the PM and the trailer to the crew in the field. That takes patience, empathy, great communication skills.
And training, presumably.
Lots of training and support. The BIM handbook mentions needing initial BIM training, even for, say, rebar installers who might still need the information officer, the Contech, to navigate the model for them and print screenshots.
So it's very hands-on support, bridging that gap between the tech experts about the high priest class, as one source called them, and the everyday users, the laity.
Exactly. Ensuring technology isn't just implemented, but truly adopted and used fully by everyone. Fostering digital literacy, showing people how these tools make their jobs easier, not harder, breaking down those barriers.
And that's not just about clicking buttons, is it? It's about changing mindsets, overcoming that natural resistance to doing things differently.
Absolutely. The goal talks about how new ideas can leave people confused. You need a thinking process to examine it early, not just react when problems pop up.
So the Contech facilitates that organizational learning, guides teams to evaluate and integrate tech systematically.
Yes, rather than just imposing it top-down. That proactive approach helps overcome resistance, builds a more adaptable workforce, and actually fosters innovation from the ground up. Workers start seeing possibilities.
And by educating everyone, the construction manager, supported by the Contech, can maintain their leadership role with appropriate application of BIM.
Right. It's about fostering collaborative futurecraft, developing smart citizens within the construction process, as the city of tomorrow puts it. Creating a workforce that uses the tools and helps shape how construction evolves. They become the champions of change.
Okay, another key role. Ensuring those digital threads between the office and the field stay strong, that seamless data flow.
Critical. Imagine data flowing directly from the 3D model right into the surveyor's equipment on site. That's the goal.
Real-time bidirectional flow, closing the loop between design, plan, and execution.
And Construction Management Jumpstart confirms this happens. Data from the BIM model can be used to assist with the layout of materials and systems in the field. Relevant info gets loaded directly into the surveyor's equipment.
Eliminating manual transcription errors, ensuring precision.
Exactly. That surveyor with the Tremble station can capture site conditions and immediately compare them to the BIM model. Identify deviations instantly.
And with all those multiple database structures in BIM, Document control must be intense.
It's very important, as the CMA standards state. And the Contech or BIM integrator is explicitly responsible for document control, maintaining integrity, version control, accessibility, preventing costly mistakes from using old info.
That level of integration, that direct data flow, it must make a huge difference in accuracy and reducing rework.
It's a cornerstone of modern construction, minimizes delays, ensures what's designed is what gets built. Precisely.
And does this extend to quality control as well?
Yes. That comprehensive oversight includes monitoring contractor compliance with the quality level expected, using digital tools to verify work, assisting trades with precise positioning, like Skanska did with laser scanning.
So the Contech uses tech to ensure quality standards are met and fix issues early.
Proactively identify and resolve quality issues before they escalate. Provide real-time feedback. It leads to higher quality, fewer defects, happier clients, better reputation.
Strategic imperative driving competitive edge and innovation.
So the Contech isn't just managing the present, they're actively shaping the future. An innovator, pushing the industry into that third industrial revolution we talked about.
Exactly. It's not just incremental improvements. It's a fundamental shift in how we make and build things, moving beyond traditional mass production.
How so?
Well, this revolution redefines manufacturing. Traditional factories got cheap by making large quantities of identical objects. Digital fabrication, it makes effectively no difference between creating identical versus unique objects.
So customization becomes affordable.
It allows for mass customization. Items can be manufactured for about the same cost, whether by the thousands or for a single unit. That's a quote from the City of Tomorrow.
Wow. How does that change construction?
Fundamentally, instead of just standard off-the-shelf parts, projects can get uniquely designed, digitally fabricated elements, custom-cut beams, unique facade panels, bespoke modular units.
Tailored exactly to the project's needs without crazy costs or lead times.
Right. Architects and builders get more freedom. They can explore more intricate, optimized, visually stunning designs, breaking free from the old constraints. Unlocking design freedom.
And this ties into prefabrication, right? Building components off-site.
Directly impacts prefabrication, which Construction Management Jumpstart calls one of the greatest opportunities to improve construction operations.
How does BIM help there?
A fully coordinated BIM model lets contractors isolate, analyze, and optimize any area for off-site fabrication. Complex assemblies, whole wall panels, bathroom pods, mechanical rooms built in a controlled factory setting.
Which means higher quality, less waste, better safety.
All of the above. Plus, significantly faster on-site assembly. These prefab components just slot into place. It's a game changer for schedules, efficiency, cost control.
Okay, so innovation is one thing. But what about the bottom line? The hard financial benefits.
The Contech delivers tangible benefits there too. The BIM handbook makes a clear financial case. It says the cost of developing the model will be more than offset by the eventual savings.
Savings from where?
In errors, shortening project duration, better use of prefabrication options, fewer workers in the field, and improved collaboration. These aren't fuzzy benefits. They're direct, measurable savings. Millions on large projects.
So investing in a Contech and digital strategy isn't just an expense.
It's a calculated investment with substantial returns. Improves profit margins, makes firms more competitive bidders.
And that 5D cost management we discussed, that plays a role here too.
Big role. CMA's standards highlight how it directly helps with options analysis and value engineering. Design mods can be matched to budgets efficiently, transparently.
The Contech can run cost what-ifs in real time.
Exactly. Assess cost implications of different design choices instantly. Helps the team make informed decisions, keeps the project on budget without sacrificing quality. Cost management becomes proactive, strategic.
Are there examples of these kinds of financial impacts?
Well, think back to the goal. Implementing theory of constraints principles, which is all about optimizing flow, something a Contech facilitates digitally, led to huge results in the examples, like 40% less inventory, freeing up almost $20 million in capital.
Wow. Those are the kinds of results a Contech can help unlock by optimizing the tech stack, integrating lean ideas.
By identifying bottlenecks in information flow, in project execution, ensuring resources are used efficiently, it leads to significant financial advantages, a stronger competitive position. Digital transformation becomes a profit center.
Okay, construction is famously risky. Delays, cost overruns, conflicts. How does the Contech help mitigate that risk?
Technology, wielded by the Contech, provides powerful tools for foresight, seeing and mitigating problems before they blow up. This proactive risk management is maybe one of the most compelling arguments for their strategic importance.
Moving from firefighting to foresight,
Exactly. And a prime example is clash detection. We touched on it earlier.
finding where things collide in the 3D model.
Right. Construction Management Jumpstart defines it. Effectively identifying unintended material or system interferences. And CMA standards add that this virtual true space checking can combine multiple models from disparate sources, structural, architectural, MEP, all layered together.
So you find that duct hitting that beam in the model.
Yes. Proactively identifying those conflicts drastically reduces the conflict and confusion that pops up later, instead of discovering it on site, forcing expensive, time-consuming, maybe dangerous rework.
The contact finds it digitally during design, when it's far cheaper and easier to fix.
Exactly. Finding that pipe beam clash with a few clicks instead of a cutting torch saves immense time, money, frustration. It's the power of foresight enabled by tech.
Now, does this risk management go beyond just clashes?
Oh, yes. It extends to comprehensive risk management across the whole project, using a project risk database, as CMAA standards suggest, for continuous communication and reporting, tracking, mitigation, and resolution.
A systematic approach.
Very systematic. Again, it's about planning rather than just reacting, like the goal emphasizes. The contact is central to maintaining this database, integrating data, ensuring risks are identified, monitored, and addressed with solid mitigation plans.
What kinds of risks?
Everything from supply chain disruptions to regulatory changes to unexpected site conditions found via reality capture, gathering expert judgments, assessing impacts, developing contingencies. It's a robust framework for navigating uncertainty.
Which leads to more predictable project success.
Yeah.
Better outcomes, improved safety, more efficiency.
That's the goal. Foresight enhances everything. Outro, Gotcha.
So let's wrap this up. What have we learned about the construction technologist? This deep dive, I think, it's shown us they are the essential orchestrators of technology on today's job site.
Yeah, the conductors of that digital orchestra.
They're the guides, navigating that complex intersection of traditional construction know-how and advanced IT. They're the ones making data as fundamental to building as concrete and steel.
Translating the promise of digital tools into the reality of built structures, embodying that shift from analog past to digital future.
And it's really a career guide, isn't it? For a new generation looking to blend that passion for building with a real talent for technology.
It really is. The role embodies that principle. Knowledge is most valuable when understood and applied. They make the potential of digital tools deliver tangible project success.
Driving innovation, efficiency, risk reduction.
And ensuring firms can find solutions that may be more acceptable to a broader range of stakeholders, as the PMBOK guide puts it. It's strategic. They empower firms to not just optimize, but to pioneer new ways of building.
Reshaping the landscape for the better. Smarter, safer, more sustainable projects.
That's the vision.
So what does this all mean for you, listening right now?
It means this role is here to stay and will only become more important.
And if the contact is already transforming an industry that was so analog, pushing it into this new industrial revolution, what happens next?
Good question. The pace isn't slowing down.
Right. As AI, advanced robotics, more sophisticated automation, maybe ubiquitous digital twins become commonplace, how will this role keep evolving?
What new hybrid skills will be needed? That blend of building passion and tech talent, what does it look like in 10, 20 years?
And what new frontiers will you discover in that exciting blend? Something to think about.
Definitely food for thought.
We really hope this deep dive has sparked your curiosity, maybe offered you a fresh perspective on the dynamic future of construction.
It's a fascinating time to be involved.
There's always more to learn, and that's truly the joy of discovery.